Buddy, this is a video series number one that we will be posting up on the blog site. As for introductions, I am Chad Hentz. I'm a technical solutions architect within Cisco. With me today, I have Mike Dvorkin, who is a distinguished engineer, came from our Insieme team, was a co-founder there, and also Cesar Obediente from TSA, also that covers Global Enterprise Theater. So with that, we're going to get started today and kind of talk about the concept of how the policy model and how we interact with the network is changing. And policy model is part of that, but how we should change from a conceptual model of how we interact with the network. So with that, I'm going to start off with working with Mike here. And I know you've been working with the ACI team, the Insieme team for a while. We'll start off with it. What have you been working on with the ACI policy model and conceptual models?
Right. First of all, thanks for inviting me to your first blog post. That's exciting. It's a very daring thing to do, starting with someone like me. I'm not a traditional Cisco guy. I'm a pure software guy, and I've never implemented a routing protocol in my life or done anything in the networking. So my views on networking are drastically different from majority of networking people, as you would expect. When we started Insieme, one of the things we wanted to rethink was how an application architect or someone who deploys the applications or the compute guy interacts with the network and how it can have interesting implications on the self-service environments. And if you look at the evolution of IT and where things are going, a lot of IT organizations are starting to act like service providers to the respective organizations. So what a lot of people are trying to do, basically, a guy who wants to deploy an app goes to some service catalog, allocates some VMs, and then they give him a VLAN, he puts them on that VLAN, and that's the end of the story, and they can do what you want. In reality, networking is a lot more complicated, right? You also have to figure out what to do with the firewalls, you need to figure out what to do with load balancers, you need to take care of some of the routing stuff, and all of that. And, at some point, this sort of like DevOpsy ways of doing this where the user basically gets to do everything himself starts hitting limitations, right? You basically either have to quantize what you can do, which means that you simplify functionality to like very simple building blocks that basically don't provide you what exactly you want, but get you somewhere close where it's almost acceptable. Or you start basically having chaos, right? And, there are a lot of environments where DevOps have been very successful, but they have to hire a lot of people who are very highly qualified to deal with this kind of stuff. And those organizations, oftentimes, everyone knows about everything. So one of my favorite lines is like, at some point, a DevOps guy needs to know how to deal with BGP, right? So in that way, we're basically completely eliminating the lines around the division of labor. Right, and we all know division of labor was very critical in the industrialization process, right? And that also applies to the data center environments, or actually any IT organizations. So basically, what we decided to sort of look at is how network control is actually conceptualized, right? So if you look at it, you can right away distinguish two parts. It's the endpoint behaviors, and you can argue that, endpoint A talking to a point B is what networking is all about, or if they cannot talk to each other or is restricted from talking to each other. And the rest of it can be thought of as, control of the network or control of the fabric and how forwarding and load balancing, all this other stuff works. So that was the first step. We separated the behavior of the endpoints and decided to express that as sets of groups of endpoints, and those endpoints within groups have very symmetrical and consistent behaviors amongst each other. And then they interact with other groups, and you basically apply policies on those interaction points. And the way it maps into the world of application architects, like if you think about how application architects reason about their apps, they generally have a bunch of diagrams. There are boxes connected to other boxes. They have lines. They have contracts expressed or APIs expressed as contracts. So it seemed like it was a reasonable idea to basically take the problem, the first order principles, and decompose it down to networking, where essentially an application tier or an application component, which it consists of an application, can consist of multiple virtual machines or containers or bare metal servers or a bunch of JVMs, however your application is structured. You basically have that application tier, and that application tier can be treated as a group within a network. And the group of things that are mutually consistent. So which means that you could add another instance of a server to a given group, and it basically inherits all the behaviors and basically acts like a member of a cluster, if you will, right? Or a member of some elastically scalable unit. And it basically has consistent rules of how it interacts with other things, right? So for example, if I have a set of application servers and they need to consume a database service, or like some SQL stuff that runs on a database farm, you can basically express that as group of the application service interacting with group of database servers, and database service exposes a contract, which is basically a projection of the API that the service provides. In this case, it's SQL, but it's a projection of it onto the wire, right? So the contract that is being provided by the group is basically expressing at layer 4 constructs what kind of things given group can talk about, right? And whenever someone like an application server group consumes that contract, they're basically allowed to talk on all of the subjects expressed in that contract. But at the same time, your database cluster or database farm can have management access. So it provides a management contract, and that management contract is consumed by some management applications, right? That basically administer the databases. So in that way, the functionality that is being exposed to the application servers or that are sitting with the application server group is drastically different from functionality that is accessible by the management applications. So we actually start thinking about the network and the composition of application in a very service-centric way, where you have a service, in this case database, and you draw this like protective membrane around it, which is a set of contracts that basically identify all the functionality exposing to others on the wire. And then whoever consumes given contract inherits that functionality and can communicate about the specific set of subjects. So this is a very natural linguistic model for interactivity.
So Mike, how do you think it's going to change the role of the infrastructure team with this concept about contracts and policies and the ACI model? How do you think the infrastructure team is going to handle this?
So again, it's all about division of labor. So there is you can view any policy problem as a force surface problem, right? One surface is the expression of intent. So a tenant or an application architect or application owner, whoever deploys the computing stuff, goes in and specifies how their application needs to function within the network, right? Then separately, a infrastructure owner or the networking guy specifies how Fabric operates, and it includes the regulation of like various protocols that are running within the Fabric, and it also covers what kind of things are allowed and disallowed within the Fabric, and also some basic ground rules for things to work. And the third one is basically compliance and governance, which basically says, certain things cannot do certain things, whatever happens, right? Or certain things should not be possible, right? And that's basically a set of global rules that, should never be violated. And at the bottom, you basically have your infrastructure, right? And the infrastructure has state, has a life of its own, and the idea is to run a policy loop that takes inputs from all the three and tries to affect the reality of the stuff down below, right? So basically, if you will, you can think about it as sort of minimization of discrepancy between the desired state and the reality, which is also known as a disappointment, right? And we're basically trying to minimize that, and we do it automatically in a continuous fashion, which is drastically different from how orchestration systems work. If you look at orchestration is basically a linear progression of number of operational steps. It's modeled largely after, kind of sort of like human behaviors and how humans used to interact with the infrastructure and the subsystems. So if I am on step number 7 and preconditions for step number 3 sort of went away, orchestration system cannot really deal with this. So you basically have to tear down whatever you had and like restart from scratch, or you have to make some manual corrections. So the way we're looking at the problem, rather than doing that, we like to declare a sort of like final desired state of what something needs to look like. And it can be altered at any time. But once you specify this, we figure out the best way of conversion onto that state. And we're doing it in a completely distributed fashion. We're trying to do it as close to the metal as possible so it scales and provides very nice resiliency and does not have any sort of dependency on the controller, on the controller's uptime. So, all this stuff is very resilient. However, again, if you look at the role separation within the data center, this to them it's largely an implementation detail. But the important thing is, if you allow a tenant to specify what they want, but within the boundaries of what's permitted by the infrastructure owner and the guy who thinks about like the compliance jurisdictions and all that stuff, you basically have a very clearly defined model where nothing has to be linearly defined, right? So which means that there is very little in terms of the operational dependencies in a linear fashion, where I have to ask this guy to do something, I have to ask another guy to do something else, and I have to ask the third guy. Here, you express the intent, and there are boundaries that guard what can be done, and then everything else is automatically enforced. So this way, you actually emphasize the roles and make them very clear. A lot of the stuff has been tried before. The project I worked on previously was UCS. We tried to create a very nice way of separating the compute from the storage and from the network, but at the same time make it consumable without introducing any unnecessary linear dependencies, and that model worked out quite nicely.
Perfect, thanks, Mike. So out in the market, we're starting to hear a lot about ACI being based on the promise theory, and I wanted to get your thoughts on how promise theory ties into ACI and what you've been working on over the last couple of years.
Well, ACI is not implemented on promise theory. It's been influenced very heavily by some of the concepts in promise theory. I'm a big fan of Mark Burgess, the father of promise theory. I've known him personally for quite some time now, and we actually published a paper together recently on the promise theory within networking. The way I think about the problem is, you can deal with management and control in many different ways. One of the ways of dealing with this is where you basically, rather than saying like, go do this and go do that, and you basically always executing a number of steps. The way I'd like to see it, and the same principle is implemented in the UCS previously, is why not specify what you want in a single shot? And you can change it at any point of time, but you always say like, I want this. And then allow system to basically enforce everything automatically. Because the system has got to know its state, and it has a very detailed understanding of what's going on under the hood. So this way you can self-optimize, you can avoid the problems, you can converge, you can retry automatically and all that stuff. So you take the burden of like the retry and sort of like doing intelligent things away from the user. And you basically build it into a machine that automatically enforces all of that stuff. Another part of the promise theory, and if you look at Burgess' writings, is the sort of enforcement through a very large hives of distributed agents, where each agent is a fairly autonomous system that consumes policies and understands what to do with them, and it basically tells you, I'll do it. It doesn't guarantee it will do it, but it will try to do its best to enforce the policy, and sometimes it cannot enforce it in the beginning, and then it converges and resources become available, and it basically makes systems a lot less fragile, because oftentimes, like for example, especially if you're dealing with hardware, you might want to configure a resource and it's not available. And it's not available simply because like you forgot to delete something, and as soon as something goes out of scope, you have resource available again, and you can basically converge. In the traditional management models, such thing requires a lot of pain. So you really have to make sure that you delete before you add and all of that stuff. We're trying to remove this sort of concern from the user scope. The user should not care about this. The user should basically say, I want it to be like this. Whatever it takes, you have to converge. And we converge as resources become available or through retries. Sometimes things are, like for example, if the switch went down, you cannot manage it. What's going to happen? You cannot manage it at all? Or should you be able to specify some desired state for the switch, and when it comes back, it will basically converge onto the policy and will render it, and everything's going to be peachy creamy. So that's the extent of how we think about the promise theory and why promise theory is good for us. We could take it to much greater depths. in implementation, but we wanted to build a system that's largely practical and very stable and scaled well. So, there is religious theoretical stuff and there is practical implementations. So in our efforts, we try to confine the problem to something that's largely implementable and something that can run in the production environments without any hitches.
So that's great, Mike. So quick question on the, you published a paper on promise theory, but also you drafted an IETF draft for OffFlex. And there's been a lot of talks about OffFlex and, how we leverage ACI leverage OffFlex. Can you give us a quick overview on OffFlex and the advantage of the OffFlex?
Well, OffFlex, despite all of the marketing around it, it's basically a very simple concept. What we try to do is we try to build an open source policy agent that can enforce various policies as close to the subject matter or as close to the metal as it can. So basically the idea behind it is you have a piece of software running in the device. Like, for example, you can run it in the hypervisor on a host or on a guest. It doesn't really matter, or you can run it in a switch. And that policy agent responds to various changes in the network, including attachment of endpoints, right? And whenever there is a change, we trigger it as a trigger. And what happens is we resolve a corresponding policy, and we render the policy locally and try to enforce all of the rules implied by the policy in a continuous policy enforcement loop right within this agent. So this way, the way you interact with the policy servers and other components of the controller architecture is very loose, and you don't require any of the chatty protocols, right? So which means that things can scale a lot better, and the controller does not have to think about enforcing things in the gory detail, especially in the diverse environments where you have heterogeneous composition blocks. The complexity of the controller, because it would have to deal with a lot of diverse things, grows exponentially. So by providing this agent, we create this nice insulation layer that provides all of the enforcement function as close to where the subject matter is, without complicating the architecture and functionality of the controller itself. It seems like a very simple concept, and it's been, it's been deployed and developed in many other parts of networking. Like, for example, that's how wireless networks work. If you think about a guy driving with a cell phone, he goes from one tower to another tower. There is no fast orchestration system that configures those towers, right? As soon as one tower sees the guy, it basically resolves a bunch of policies and it configures things locally without any sort of involvement of some giant brain. The giant brain just basically holds policy information that's being resolved. And as soon as the guy leaves the tower, that policy is basically get unresolved. You forget about this and you basically remove the configuration after whatever timeout period. So these kind of things are really easily achievable with the agents. So, and OffFlex basically provides very similar things. So, for example, if I place a VM on a given hypervisor, we treat it as the endpoint attachment. We figure out what this VM is. We'll look at what networks and which groups the Phoenix within the VM or the container ports connect to, and then from that we know which policies to resolve and how to enforce them. And the rest of it is basically endpoint resolution, and that's also built into the OffFlex protocol.
Mike, what companies are we working with from an OffFlex perspective out there in the industry outside of Cisco?
So surprisingly, a lot of Cisco's competitors have been looking at this. So we've been working with companies large and small. So one of the biggest contributors to this is Midakura, Intel. There is interest from guys like Nuage. There's been interest from several startups, including what's the name? The PlumGrid. There have been conversations with Red Hat. They have been conversations with HP, but it's unclear whether they will get into supporting this. But there is general agreement that at some places this kind of stuff is very interesting. especially as we go towards constructs of like NFV and pure container-based virtual or devirtualization, whatever you call it, like when you use containers, where top-down management is starting to suffer from scalability issues, and agents can solve a lot of the problems. The way our agent is built is it's not specifically built for networking. It can also be applied to storage and compute. So you can theoretically build very interesting constructs, and that attracts a lot of partners you would never imagine would care about. Like, for example, like within the Intel, it's not just the networking guys; it's the guys who are working on the rack scale architecture, and for them, having a little policy agent that can control things within the rack of compute is a very interesting concept. We also had a number of conversations with the open network Linux guys. They really like the concept. They think that embedding something like Upflex into the ONL has a lot of merit, and as a means of like distributed control and configuration. So there's great interest. Honestly, we never expected it to be like this. Also, there is interest from layer 4 to 7 vendors, both in context of integration with the ACI, but as well as just purely looking at it from the standpoint of how it can be utilized in a completely open source control environment, such as ODL, where again you can overcome some of the scalability issues of those controller platforms.
So thanks, Mike. So one thing that now we're about to close the session, but one thing that we talk about UCS, and I know you were one of the people co-founders or that wrote a lot of UCS code, right? So with the success of UCS, right? I'm sure you heard the news about a couple of weeks ago where we became #1 in revenue in North America. You did a lot of work. Now you ACI, ACI is kind of old news for you now. You're kind of moving forward. It'd be great if you can let us know what is your thoughts. Obviously you don't have to disclose what you're doing because it might be secret. But what is your thought of ACI in 6, 12, 18 months from today? Where you see ACI being, or where do you want it to be?
So if you think about it, ACI, it's basically a fabric, right? If you think about the data center as a sort of fabric computing entity is a very interesting concept. So pulling in the compute and putting under policy of ACI in a way that basically still honors the separation and division of labor within the data center, but also being able to scale very large compute environments and completely automating it is a very interesting thing. Another thing that needs to happen is some of the work that's associated with the OVS and the Upflex that we're doing, especially for the OpenStack and the Docker environments, where we'd like to do a lot of the policy enforcement right in the hypervisor or right in the host. So that should be extended not only to the containers or bare metal things or VMs. We also would like to extend it to regular process. Like, for example, you can have a host running a very large number of JVMs, and Java is still very popular within enterprise. And rather than treating each of those JVMs or wrapping them within a VM or a container, we can treat them anonymously and understand their semantics and apply all of the policy rules right in the hypervisor, even if the VMs try to switch locally, or JVMs can try to communicate locally. So this way, we can do the full policy enforcement across physical, virtual, the sort of like applications or containers or anything in between. This is very exciting. Some of this other stuff we're looking at is how to provide better visibility into the fabric. So we're looking at both integration with a lot of the tools that are usual suspects, such as Splunk and all that stuff, and building some stuff on top of Splunk to provide nice debuggability and anomaly detection. We're also working on interesting analytics platforms for solving some of the security and anomaly detection problems. And last but not least, we're spending a lot of time in the open source, specifically Open Daylight and OpenStack. And The idea there is to introduce the concepts of group-based policies that are inspired somewhat by the ACI model. So again, to basically provide an interface that is consumable by the application architect, so they can control what they'd like to see and how they'd like to how they would like to see network working for their specific applications without putting any burden on a network team. Then there is a lot of stuff we're trying to do for containers. Containers are a very exciting thing. I think for devirtualization is coming, and the significance of VMs within the next 5 years will decline greatly. And containers such as Docker will be very, very important, running on top of things like CoreOS and other innovative operating system constructs. Containers have much greater densities than VM. So, for example, you can put hundreds of containers onto a single host, and it doesn't chew up too many resources, and they're super low overhead. For that, you need to provide very nice policy enforcement. So a lot of the stuff that communicates locally needs to do it with great efficiency and without sacrifice of any security, right? And that's a very exciting area for us. But
Excellent.
Going further, there can be many things. It's all software. Once God gave us C compiler, anything is possible.
There you go.
All right, thanks a lot, Mike and Cesar, and everyone for your time today. I hope you find this useful. We really appreciate, Mike, again, your time for going through a lot of the stuff with us and helping our customers to understand better what's going on with Alphalax ACI, where the thought process behind it came from, and where we see things going in the future.
Well, thank you guys. It was a pleasure.
Thanks. Take care.